Hello everyone and welcome back to physics class. Today we are going to be revisiting the previous topic of graphs, and we're going to specifically be looking at how you can determine the slope of a line. So let's just go over the basic equation of a line. If we recall, the equation of a line is written as this: y is equal to ax plus b. Now x represents our independent variable, right? If we remember that, that is our independent variable. And this is your point along the x-axis. And then we have our dependent variable, which is represented by the y. So this is your dependent variable right here. And that value is given by the y-axis. Now, we also have these two other letters here. We have the a and we have the b. A is actually our slope. So A is a slope, which just describes how steep the line is. And then B is our y-intercept. So this is where the graph will intersect, cross over the y-axis. So to determine the slope of a line on a graph, you need at least 2 points on said graph. The formula for the slope of a line is as follows. It's rise over the run. So if you imagine a graph that has a line that's like this, and we're looking at two parts to it. We're looking at the rise and the run. So the run is basically how far along the x it goes. So it's basically from the it's the horizontal kind of shadow. If you were to take a shadow of the actual line, if you were to cast a light, let's say we have a light up here. Let's say we have the sun up here, and it's casting light on this line, and there's a shadow. This shadow would be your run, essentially. You can think of it that way. So this is your run. It's how wide it goes between these 2 points specifically, right? These are the 2 points, point 1 and point 2. So point 1 is here, point 2 is here. Your rise, on the other hand, will be how high or how low it goes. So how much does it rise or how much does it fall? Now, rise over run is a good way to remember our slope. But we also have this other way as well here. So if we have these 2 points, and let's say that I actually wanted to label these points here. So this is just going to be, this point here is my x1 and then y1. So those are the coordinates of this point here. And then this point here, I have coordinates of x2 and y2. So if I have those 2 points like this, then I can plug it into this formula right here, which is y2 minus y1 over x2 minus x1. So let's take a look at an example. Here we have a graph, and we know that it is sloping down. The reason why we know it's sloping down is because we always read the graph from left to right. So we can see that it is actually sloping downwards. We can see that it's tending to travel lower and lower as we read the graph along. So let's take a look at how we can find the slope of this particular example here. So I'm going to choose this point right here. This is going to be my point 1, and then I'm going to choose this point here as my point 2 right there. So I'm going to use my formula. A is equal to my rise over my run, okay? So my rise is dealing with the y's of this. So I have y2 and then this is y1. So I'm looking at just the y values of the coordinates first. So this is going to become 3 minus, so it's y2, so 3 is my y2, and then I'm subtracting my y1 from that, so minus 5 from it. And then I'm going to take a look at my x's. So this is my x2, and this is my x1. Now the bottom is going to be similar. I'm going to be taking my x2, which is 3, and I'm subtracting my x1 from that, which is 0 in this case. So now I have this weird kind of fraction looking thing. So we're going to take the top and the bottom. We're just going to do our subtraction. So 3 subtract 5 will give us -2. And then 3 subtract 0 just leaves us with 3. And this is our answer. We have a slope that has a -2/3 value to that slope. If you have any questions about this, please don't hesitate to ask. And like always, I will see you next time.